Hello students, welcome back to today's class on playing with numbers, and in that we're going to discuss about HCF and LCM, highest common factor and least common multiple. My name is Avinash. I'm a graduate from IIT Kharagpur. Let's start today's session. So let us try to understand first of all what is HCF. The name itself says that highest common factor. Common factor, you know already what are factors, but what do you mean by this common factor? Whenever we are discussing common, that means it should be common between two numbers or three numbers or four numbers. We are taking one number and writing the factors and bringing the common factor is not at all correct. Common means we should have at least two numbers. From there we need to take the common factor, right? And if we have more than one common factor, so out of all those, whatever the highest is, so that is called highest common factor, which is a HCF. Let's try to understand more about that. The number that divides all the given numbers, the number that divides all the given numbers is called a common factor, is called as a common factor. For example, we have 12 and let's say we have 18. So, which number divides all the given numbers? Okay, I know 2 divides these two, correct? Even 3 divides these two numbers. 2 and 3 divides 12 and 18 exactly, leaving the remainder 0. So, 2 and 3 are called the factors. 2 and 3 are called the factors, okay? And now, let's come to 2 and 3 are the factors of both 12 and 18. So, these are common factors. These are not the factors of just 12 and just 18. These are the factors of both the numbers. And now, the greatest among the common factors, the greatest out of the 2 and 3, which is 3 here, which is the greatest among these factors is called highest common factor. The greatest out of these two is called highest common factor, right? So, let's move ahead to understand more about highest common factor and how to find highest common factor. So, what is the next one we're having? HCF is also called as GCD, greatest common divisor, or highest common divisor, or greatest common factor. HCF, GCD, HCD, GCF, all these represent the same, that we need to find all the factors, all the common factors, and in that the highest one. The highest one is called the highest common factor, right? So let's move ahead to learn the next one. So as we are discussing about the factors, let's try to understand more in detail about the factors, okay? A number A is a factor of the number B. So let's say we have a number B, and to this B, we are trying to find all the factors. But what are factors? What do you mean by that? A number A is said to be a factor if A divides B. If A divides B. For the number 12, if I say 2 is a factor, I know 12 divided by 2 is equal to 6. It is dividing. So I can say that for number 12, 2 is a factor. Even 3 is a factor because the 12 by 3 is 4. Yes, it is a factor. Every number is factor to itself. You can divide 12 by 12, you will get 1. So yes, even 12 is a factor. You can divide with 1. 12 by 1, it divides exactly and you will get the same number. But still, you can divide that. So 1 is factor of every number. So we have few important points here to note it down. Every number is a factor to itself. Number 5 is a factor of 5. Number 10 is a factor of 10. 100 is a factor of 100. In that way, every number is a factor of itself. The same way, the next one we're having is 1 is a factor of every number. For every number, I can divide 12 by 1, 13 by 1, 14 by 1, 100 by 1. I'm getting the same number, but still, I can divide that, right? We can divide. So we can say that 1 is a factor of every number. You can divide 12 with 1, 13 with 1, 14 by 1, 15 by 1, whatever number it is. You can divide, you will get the remainder as 0. So we can say that 1 is a factor of every number, okay? So we have few questions here. Factors of 21. So tell me, what are the factors of 21 we are having? 21, I can say it is 3 times of 7 or 7 times of 3. 3 times of 7 or 7 times of 3. See here, factors of 21, we can write 3 into 7. So 3 will come, 7 will come. 1 into 21. 1 into 21. Even 1 and 21 are also the factors. 1 into 21. 3 into 7. 7 into 3. 21 into 1. All these numbers will give you 21. So these are the factors of 21. Factors of 24. 1 into 24. 2 into 12. 3 into 8. 4 into 6. 6 into 4. 8 into 3, 12 into 2 and 24 into 1. All these are factors, right? If A divides B, I can divide 24 by 2, I can divide 24 by 3, 24 by 4, 24 by 6, 8, 12, 24. We get a perfect remainder 0, right? And the same way we have factors of 75. So I'm leaving this for you. So please try to find this factors of 75. Maybe 5 may come and still lot many other numbers may come. See whether 3 can come. Okay, so all these numbers are factors. Okay, so let's move forward to see what are the common factors. When I explained you about the highest common factor definition, we said HCF means highest common factor. So first of all, let's try to understand more clear about common factors, and then we'll go to find highest common factor, and also we'll find different methods, we'll learn different methods to find HCF or GCD, greatest common divisor. Okay, so find the common factors of 75, 150 and 45. Find the common factors of 75, 150 and 45. So how to write all the factors? Okay, there are different methods, but let's try to understand that 75, it is, I know that 1 into 75. 1 into 75. So both 1 and 75 are the factors. Okay. For the number 75, 1 is a factor, 75 is a factor. So can I express that with 2 into something? No. 3 into? Yes, I can. 3 into 25. So 3 and 25 are also the factors. 1, 75, 3, 25. With 5 can we cancel? Yes, how many times? 5 15s. 5 15s. So 5 and 15. 5 and 15, correct? 1, 3, 5. Next, 7, no. 6, no. 8, 9, 10. Can I cancel with 10? No. Okay, anything else? I don't think so. So, yeah, any more factors you can try to find if you can. 1, 3, 5, 15, 25, 75, maybe 10, no, 12, 13, 14, I don't think so we will get any other number. But there is a method, okay, don't worry about that. I'll explain you a method how to get the factors, okay. So now we'll go with 150. 150, I can write it as 15 into 10 or 1 into 150 first of all. So 1 and 150 are the factors. 2 into 75, we are again with this number 2 into 75. So 2, 75 are also the numbers, are also the factors. 3 into 50, so 3 and 50 are also the factors, right? And 4, I don't think so. 5, yes, 5 into 30. 5 into 30, so these two are the factors. Anything more? 6, 7, 8. What else can we write? With 8 or maybe 15, 10s, no. So with 10 we can get 10 into 15, 10 and 15, and just try to find what else other factors you can find. Okay. So what more? 5, 30, 6, 5, 25. We left 25. 6 into 25. 6 into 25. See how difficult it is to write all the factors. Sometimes we may miss that, right? So there are some methods which we can learn to find all the factors without missing anything. Okay. So next, what about 45? 45 is 1 into 45. So 1, 45, with 2, no, with 3, 15s, 45, 3 into 15, and 4, no, 5 9s are 45, so 5, 9. Anything else? Maybe with 15, 3, 45, and 1. Okay, I think that's all. But you can just try to find. So now, see what are all the common factors between all the numbers. Factors which are common between all the numbers. Okay. So 1 is common for all of this. Okay, 1. Anything else? 3 is a common factor. 3 and 3. Yes. 3 is a common factor. 5 is also a common factor. 5 and 5. Anything else? 15 is there, but even less than that, any 10? No. Okay, so 15 is there. 15 and 15, right? So 15 is there. Anything else? Just once again, please cross check all this. But now, these are the common factors. Okay, these are the common factors. But out of all these factors, whichever is the highest, so that will give you the highest common factor. That will give you the highest common factor. 15 into 3 times, 15 into 5 times, 15 into 10 times. So 15 is a common factor for all of these numbers, right? There are several methods to find LCM as well as HCF, highest common factors. So I'll tell you that. So, but this is the method how to write all the factors. Okay. The next one, before going to find the methods to learn how to find HCF, we need to understand what are prime numbers and what are co-prime. So first, let us try to discuss what are prime numbers. Prime numbers, the number whose only factors, are 1 and the number itself. 1 and the number itself. For example, we have number 3. The factors of 1 and 3, no other number can come here. 17, 1 into 17, 1 and 17, no other number can come, no other factor can come. These type of numbers where the factors are 1 and the number itself are called prime numbers. Right? So let's move forward. We have several examples here, 2, 3, 5, 7, 11. All these are examples of prime numbers. You can see 5, it is only 1 into 5. You cannot have any other factor. 7, 1 into 7, 11, 1 into 11. You don't have any other factors, okay, except 1 and the number itself. Right? So 2 is the smallest prime number. 2 is the smallest prime number, and all prime numbers except 2 are odd. Okay. 2 is the smallest prime number. What about 1? You can ask me, what about 1? See, what is the definition? 1 and itself. We have 2 factors there. But for the number 1, you only have the factor 1. For the number 1, you can write 1 into 1. You only have the factor 1. Only one factor. But for the number 2, if you take, it is 1 into 2. 1 and the number itself. So that is the reason 2 is not considered as a prime number. 2 is not considered as a prime number. Okay. So 1 is not considered as a prime number. 2 is the smallest prime number. 1 is not considered as prime number. 2 is the smallest prime number. The very first prime number in the positive numbers is 2. Okay. All prime numbers except 2 are odd. All prime numbers except 2 are odd. You can write 4, but it is 2 into 2. It's not a prime number. 6, not a prime number. Because all the even numbers have a multiple 2. All even numbers are divided by 2. They can be divided by 2. They have a common factor. They have a factor 2. Any even number. So that is the reason in the even numbers, only the number 2 is a prime number. Rest all the even numbers are composite numbers. And except the number 2, the remaining all prime numbers will be odd. Alright. So let's move forward for the next one. So the question is, and the smallest number having 4 different prime factors. 4 different prime factors. Can you find the number? Can you find me? Beautiful question. 4 different prime factors. Tell me what are prime numbers, 2 is a prime number, 3 is a prime number, 4, 5 is a prime number, 6 is not a prime, 7 is again a prime. 2, 3, 5, 7. So out of this 2, 3, 5, 7, we need to find the number, the smallest number. So smallest number is nothing but the number which has these 4 as the factors and no other number. You can have into 3, into 4, into 5, into 10, into 20, but those will not be the least or the smallest number. Smallest number will be multiple of these two. Okay, 3 2s are 6, 6 into 5 into 7, 6 5s are 30, 30 into 7, 30 into 7 is 120. Sorry, 30 into 7 is 210. 30 into 7 is 210, right? 30 into 7 is 210. Okay, so let's move ahead. Let's try to move ahead to find the next concept, composite numbers. As we just now discussed prime numbers, let's try to understand what are composite numbers. Okay, the numbers with more than 2 positive factors. More than 2 positive factors, that is the only difference. Prime numbers has only 2 factors, but composite numbers has more than 2 factors that are called composite numbers, and we have few examples here. Number 4, if you take 1, 2 and 4 the factors, there are 3 factors. 9, 1, 3 and 9 are the factors, more than 2. 12, 1, 2, 3, 4, 6, 12, we have a lot of numbers here. 14, 1, 2, 7, 14, 7 2s are 14, so all these are factors. Okay, so more than 2 positive factors, so such type of numbers are called composite numbers. Clear? So let's move forward for the next one. 4 is the smallest positive composite number. Is that correct? Let me see what is that. 4 is the smallest positive composite number. What are the numbers? What are the positive numbers we're having? We have number 1. But I told you, number 1 is not a prime number and it's also not a composite number because it should have more than 2 factors. 1 does not have that. Number 2, 1 and 2 itself. Okay, this is a prime number. Number 3 is a prime number, 1 and 3. So the very first composite number will be 4, which has the factors 1, 2 and 4. Okay, 1 is neither prime nor composite number. This is very important to remember. Number 1 is neither a prime number nor a composite number. Okay, so let's move ahead to find what are co-primes. We discussed the prime numbers, we discussed composite numbers. Let's try to understand what are co-prime numbers. Okay, the numbers which have only 1 as a common factor, only 1 as the common factor are called co-primes, which are also called relatively prime numbers, Okay, so let's try to take an example. 2 and 5. 2 is 1 into 2, 5 is 1 into 3. Sorry, 1 into 5. 5 is 1 into 5. So there are no common factors between them except 1. Except 1, there are no common factors. What about 3 and 8? 3 is 1 into 3. And 8 has 1, 2, 4 and 8 as the factors. Although 8 is not a prime number, these two have only 1 as the common factor. 6 and 25. 6 and 25. Both are not the prime numbers, but 6 has the factors 1, 2, 3, 6. 25 has 1, 5 and 25. These two don't have any other common factor except 1. Such type of numbers are called co-prime numbers. So let's try to understand more about that. Okay, 2 prime numbers are co-primes. 2 prime numbers, take any 2 prime numbers, 17 and 19. They don't have any other common factor except 1. So any 2 prime numbers are always co-prime numbers. 2 composite numbers can also be prime. Just now we discussed, right? 6 and 15 maybe. What is the example we have discussed in the previous slide? 3, 8. Okay, so 3, 8 are not 3, 8, something else where both composite numbers. 3 is a prime number. Once again, 6 and 25. Sorry, 6 and 25. Okay, 6, 25 are both composite numbers, but they are co-prime. 1 is a co-prime to any number. 1 is co-prime to any number. 1 and 50. 1 and 50 if you take. 1 and 50. 1 and 100. 1 and 1000. The common factor will always be 1 because 1 has only 1 as a factor. 1 has only 1 as a factor. So 1 and any number will always be co-prime. Right? So let's try to understand more about this one. So now let's try to understand about a prime factorization method, and from there we'll try to understand how to find HCF. And in the next lecture we're going to discuss about LCM. Okay, so what is prime factorization? What is prime factorization? When a number is expressed as a product of its factors, we say that the number has been factorized. Okay, for example, if I take a number 12 and I write 1 into 12, it is being factorized. 1 and 12 are the factors. 3 into 4, it is being factorized. Okay, the process of finding the factors is called factorization. So this process, whatever we learn now, is called factorization. Okay, and in the methods of prime factorization, we'll be discussing two methods. One through division method and the other through factor tree. We say it as a factor tree. We find the factors and here we divide the numbers with some prime number. So there is a difference between these two, but both of them will give you the same answer at the end. Okay, one is the division method and the other is a factor tree. So let's try to understand more about that one. Factorize 84 by division method. Factorize 84 by division method. So 84, let us try to divide that one. With which number? Let us try to start with the prime numbers. Number 2. Okay. By division method, if we go factorization 2 into 42. 2 into 42. Again 2 into 21. Next 3 into 7 and 7 into 1. So 84 can be written as a 2 into 2 into 3 into 7. 2 into 2 into 3 into 7, that is a division method. Okay, this is how we can try to factorize that 2, 2, 3, 7, correct? Let's move ahead for the next one. Wait, 1 second. Yeah. The prime factors of 1710 are. The prime factors, that means we need to factorize that. Okay, 1710. Can we do with 2? Yes, it is an even number. We can do that. 2 8s are 16. 8 2s are 16. So we are left with 1. So this is 1. 2 5s are 10. We are just again left with 1 more. And 2 5s are 10. So now can we go with the 2? No. Can we go with 3? Yes, I think we can go with 3. So 3 2s are 6, 2 is left, 3 8s are 24, 1 is left, 3 5s are 15. 2 into 3 into 285. 285, let's try to divide with the 5. 5 5s are 25, we are left with 3, 5 7s are 35. 5 7s are 35, okay. 57, I think we can again come up with 3. We can again come up with 3. Okay. So 3 ones and 3 nines. 3 19s. So 19 is a prime number. So we can say that it is equal to 2 into 3 into 3 into 5 into 19. 19 is a prime factor. 5 is a prime factor. 3 is a prime factor. 2 is also a prime factor. Prime factors of 1110 are 2, 3, 5 and 19. These are the prime factors. So that is how you can try to bring all the factors behind them. Okay, so let's move ahead to see HCF by prime factorization method and how to find HCF through writing all the prime factors. So that we are going to discuss in the next lecture, right? I hope you understood what are prime numbers, what are composite, what are co-primes. We have learnt lot of things, and using this method in the next class we are going to find HCF and then we'll continue with LCM, right? Thank you so much, friends. Stay tuned to get the next lecture. Thank you.
Hello everyone. So now we'll be discussing about length and its units. So my name is Shashan Reddy. I'm a graduate from IIT NEET. Let's go into the class. Now length, as we know, is a very simple thing, right? But before length, we'll go into something general. What is that? Measurement. So what does a measurement mean? That is the question. We measure many things. We measure mass, we measure money, yes or no? We measure length, we measure time. But what does measurement in general mean? What it means is, whenever you say measurement, what you do is you compare an unknown quantity with a standard quantity. What does that mean? I'll give you a simple example for that. Let's say I have to measure the distance between two cities. I'll take Hyderabad and I'll take Chennai. Okay, so I have to measure the distance between the two cities, Hyderabad and Chennai. So the thing is, before this, we don't know what the distance between Hyderabad and Chennai is. We don't know what is the distance between Hyderabad and Chennai. That means here distance between Hyderabad and Chennai, distance between the cities, I'll just say distance between the cities is what? Is unknown. We don't know what the distance is. So this here will be an unknown quantity. What is that going to be? Unknown quantity. Simple. Now we have to measure the distance between them. We'll measure it, right? And when you measure, generally you write it in terms of what? In terms of kilometers, right? Let's say the distance between these two cities, for example, I'll take it as 400 kilometers. I just take an assumption, okay? It could be 400, it could not be 400 also, I don't know. The thing is, let's say you measured it and distance between Hyderabad and Chennai, you got it as 400 kilometers. Now what you are doing is, you are writing this unknown quantity, that is the distance between the two cities in terms of kilometer. And what is a kilometer? Kilometer is a standard unit. We know what 1 kilometer is exactly. So here kilometer refers to what? Refers to a standard unit or a standard quantity. Yes. So to express the distance between two cities, what are we doing? We are comparing the unknown quantity, this distance, with kilometers. And what we are saying is, this distance is 400 times kilometer. How many times? 400 times kilometer. So we are comparing this with kilometer and then we are writing it down. So this is measurement. That is what? That is measurement. So coming back, it is what? Comparing an unknown quantity with a standard quantity. Unknown quantity, distance between cities, standard quantity is kilometer in our example that we have taken. Good. So this is called as measurement. And as you know, we just went into the example, right? The distance between two cities can be compared with a known quantity, like kilometer. And we have taken an example as 400 kilometers. Yes or no? So in that, the number is 400 and the unit is kilometer. The number is 400 and the unit is kilometer, and that combined, this 400 kilometers is the measurement. So measurement has two parts. The first part is the number and the second part is the unit. First part the number and second part the unit. Simple? Clear? Good enough, right? We'll go into another example then. We'll take similar example. Consider the distance between two cities as 150 kilometers. 150 kilometers is the measurement, and for that 150 kilometers, 150 is the number and kilometer is what? Kilometer is the unit. So every measurement, every and any measurement will have these two parts for sure. One is the number, other is the unit. You can take any measurement. You can take time. The time interval between two events, let's say 1 minute. 1 is the number, minute is the unit. Let's say time interval is 200 days. 200 days. 200 is the number, days is the unit. Right? The mass of an apple, let's say 200 grams. 200 is the number, gram is what? Gram is the unit. So any measurement will have both of these parts, number as well as the unit. Got it? Understood what measurement is? Good. So that is the basic. Right? Then we'll go into what length is. This chapter will mostly be dealing with length. Right? So we'll start with length. So what is length? Now length is very simple. It is nothing but the distance between 2 points. So when I say, let's say I have to measure the length of one side of this table. So this is the first point, I'll call it as A. This is the second point, I'll call it as B. The distance between these 2 points A and B is the length. Simple. If I want to measure the height of this boy here, right, this is, let's say this point is A, this point is B. The distance between these 2 points is the height, and height is another way of length. Another type of length, simple. Right? That's it. Distance, we know what distance is, we know what length is. Right? When we measure width, breadth, depth, height, etc., they are nothing but length. So we actually measure what? We actually measure length. Good? Now if I ask you, what are the units of length that you use generally? In everyday life, what units of length do you use? Yeah? Centimeters, kilometers, centimeters on a scale, kilometers, distance between cities, length between cities. Right? For height, we use foot or feet. Yes or no? So these are the common units. We'll go into all of them one by one. Understood? Okay. But the thing is, how did cavemen measure length? Forget about cavemen. How did our forefathers, how did they measure length? Now nowadays we have scales and all, but did they have scales then? No. Scales are invention of humankind. We invented them. So long back there are no scales. So how did they measure length? For that, we can understand that through our tradition also, right? I'll just give you some examples. There are different units. They also used units. What are they? We'll go into some examples and then you'll understand, even today we use this. Whatever they used, even today we use. How? Let's see. One of them is this, foot. Can you see that, everyone? Clearly? Right? So foot, it is equal to length of the foot, simple. Now, you do this, right? I mean, at least I used to do this. When I used to play cricket or when I used to play football, I'll take football for an example. To measure the length of the goal, or you can say width of the goal, how do you measure it? You don't get scale and measuring tape every time, right? How you measure is, we just measure it using our feet. 1 feet, 2 feet, 3 feet, 4 feet, 5 feet, 6 feet. Yes or no? Right? So foot or feet is something we use even today. Then ancient people also use them. To measure what? To measure length. Yes or no? Even for a cricket pitch, we use feet. 1, 2, 3, 4, 5, 6. Right? Yes, so something that they used. So here the foot itself will be the unit. When I say the length is equal to 3 feet, what am I saying here? 3 is the number, feet is the unit. So the length of the foot itself was considered as a unit. Got it? Then you have foot. There are other examples also. Obviously there was something called as a cubit. What was a cubit? It is, you can clearly see here, the length from the elbow to the finger. Simple. It is equal to length from the fingertip to what? To the elbow. That's a cubit. 1 cubit. And if I look at this cubit is again a unit. So there are different units. There are different units of measuring length from way long back. But there is a major disadvantage of them. Major disadvantage of using cubit to measure length. Using foot to measure length. And most of you might have already experienced that. I'll say what it is. We'll understand it later on. Don't worry. Then there was a yard. Yard is another unit which people used to use. Even nowadays they use. We don't normally use it, but if you go to any garland shop, Okay, any shopkeeper who sells flowers. Right, so they measure the length of a garland using a yard. Even today. Okay, mostly in towns you will find this. Even today, they measure the length of the garland using a yard. I told you, right, traditions will be passed down. So, units are also passed down. Knowledge is passed down. So, yard, it is equal to length of the outstretched arm from your chin. Basically, from here. Okay. This is not the chin, I know. I'm saying exactly from here to here. From middle of the face to the tip. That is yard. Good. Then they also used angul. Angul is just a finger. Finger for small lengths. Very small length, you can use what? You can use a finger or an angul. Simple. Right. Then this is the most common one, I think. Most of us use it almost daily. Yes or no? That's called as a hand span. Yes or no? From your thumb to your little finger. Thumb to your little finger. That length is what? That length is a hand span. Right? Good. We use that where we use that to measure length of a table and all. Nowadays we do it very frequently, right? Yes? Good. Chalo. So those are some ancient units. But there is one major drawback. One major disadvantages of using those ancient units, those old units. What are they? You will understand. For that, let's look into some examples. A very simple example here. We'll take two students, two kids. One is, let's say, I'll call her as Tanvi. Okay. This is, let's say, Tanvi. And this is, let's say, Anvit. Okay. The names are good, right? Tanvi and Anvit. So let's say there is Tanvi, there is Anvit, and both of them are talking to each other. Let's see what they are talking to each other. Tanvi says, let's measure the height of Ram. So Ram is a mutual friend. Ram is a mutual friend of Tanvi as well as Anvit. Tanvi says, let's measure the height of Ram. Now what does Anvit say? We'll make use of our hands. They don't have a scale, they don't have a measuring tape, anything else. So they'll make use of hand, or let's say hand span. It's like this. I'll measuring it like this. Okay. I'm measuring my height in that way. Okay. Both of them will do. Okay. Let's see what does Tanvi say. Tanvi says, okay, let me also try. She also tries. So Anvit gets the height as 11 times his hand. According to Anvit, what is the height of Ram? I can say height of Ram, if I just write it down here. Height of Ram is equal to 11 times 11 into Anvit's hand. Okay. I should exactly speaking, I should write it as length of Anvit's hand, but you understand it. So that's what Anvit told. Anvit told that height of Ram is 11 times Anvit's hand. Now let's see what does Tanvi tell. Tanvi tells that he is 12 times my hand. I mean, according to Tanvi, height of Ram is 12 times Tanvi's hand. Now this is a mistake. Something should have gone wrong. According to Anvit, it is 11 times, and according to Tanvi, it is 12 times. And Anvit says it should be 11. So they start arguing. They start arguing whether who is correct, 11 times or 12 times. But kids do not lie. Do you lie? No, right? Children do not lie. Yes? That means here both of them are speaking the truth. Then what is the issue? If Tanvi is correct, if Anvit is also correct, both of them are speaking the truth, then what is the issue here? Can you tell what is the issue in this case? Yeah? The issue would be, everyone, what will the issue be in this case? The issue would be the length of Anvit's hand and the length of Tanvi's hand will not be equal, or they need not be equal. It's simple, right? You can compare your length of the hand, okay, the palm. You can compare your palm size with your neighbor now. If you have any friend with you, sitting with you, compare it with him or her. See that whether they are equal or not. Mostly they will not be equal. Yes or no? If you're exactly of equal height, then they might be equal, but generally they won't be equal. There might be slight difference. Right? So here the issue is, when we say the height of Ram as 11 times Anvit's hand, what is the unit? The unit is Anvit's hand. And when we say 12 times Tanvi's hand, the unit is Tanvi's hand. So the issue is in the unit. The unit is not standard. Unit changes from person to person. If you take hand span as the unit, hand span according to Anvit, hand span according to Tanvi is different. That is the issue. Both of them are correct. But the issue lies where? The issue lies that the length of their hand spans are not equal. Understood? Yes? Okay, that's good. Let's continue. So, that is the reason why it is very necessary that we define standard units. Now, what are standard units? Standard units are those units which remain the same for everyone, for me, for you, for anyone else in, let's say, other countries, Africa, Russia, USA, anywhere. It should be the same. The unit should not change. One important point. Then it should not change with time. What does it mean? Should not change with time. If I have a unit today, 10 years after, 10 years into the future, even then that unit should remain the same. It should not change. So standard units are those units that do not change with person to person, with place to place, or with time to time. They should never change. That is the meaning of standard unit. See, this hand span obviously is not a standard unit. Why? Hand span for Anvit and hand span for Tanvi is different. So from person to person, the length of hand span changes. That means what? That means they are not standard units. In fact, all the old units that we have looked at, like cubit, like yard, all of them are not standard. As you grow in height, the length of hand span changes. See, from time to time, the length of hand span changes. From person to person, from place to place, they change. They are not standard. So we had to define standard unit. So what are standard units? It is a unit which is uniform everywhere. What does uniform mean? Uniform will mean the same, which is constant. You can understand uniform as constant. So a standard unit is a unit which is constant everywhere. That is, it's the same. It remains the same no matter who is measuring it, no matter the person, or where it is measured. I told you, right? It should not change depending on person, depending on the place, depending on the time. Standard units should not change. Simple? Good. Now, ancient units are not uniform everywhere, are not constant everywhere. They change from person to person, place to place, and time to time. Yes? So some examples of standard units. Now, nowadays we have too much of technology. We have defined too many things, right? So, and science starts with measurement, and measurement depends on standard units. So what are they? We have many standard units like meter, gram, kilogram, second, minute, hour, so on. Right? The units that we use today are mostly standard units. They are well defined. They are well defined in such a way that 1 meter for me and 1 meter for you is the same. For me and for you it is the same. So 1 meter here and 1 meter in, let's say, France, the same, doesn't change. It does not change from person to person. It does not change from place to place. And 1 meter now and 1 meter 10 years into the future is the same. It does not change from time to time. Right? Some examples. Good? So standard units, it's very important to understand what standard units are and why they are required. Got it? Good? Okay, let's continue. So this was a challenge. I mean, you know, right? Do you know about United Nations? Yes? What is United Nations? It's just a grouping, a group where different countries come together. So there are many such groups, international organizations. So one such group is this, which decides the units. Okay? So there was this problem. There was this problem before 1900s. Right? What was that problem? See, The Britain, UK used to use some units. USA used some units. Indians used some units. Russians used some units. Africans used some units. Everyone used to use their own units. Their own units, right? So there will be a lot of confusion, and there was a lot of confusion. I'll give a simple example. Let's say that in your class, let's say there are 40 students. And if all 40 of you use different units of length, then how can you talk to each other in terms of science? How can you tell the length I measured is this and this? How can you compare? Can you compare? No. Right? If all 40 of you use different units, you cannot compare the lengths. Yes or no? Length you measure, length your friend measures, length your another friend measures. You cannot compare them if you use different units. So, if all of you use one unit, then it would be very easy. Yes, the same thing happened here. Many countries, many people used to use different units, and then around 1900s, scientists from all over the world, from different countries came together. They came together, they sat, they discussed, and they told that, we will be using some international system of units. They fixed that, for length, meter is the unit. For mass, kilogram. For time, second. And everyone will follow this. They fixed it. And that they call it as international system of units. Okay, that system they call it as what? International system of units. So look at the points here. Internationally, scientists have discussed and adopted a standard system of units, and the standard units are called International System of Units. There's short form to it. They are called as SI units. It's very important to understand this. SI units. What does that mean? They mean International System of Units. Now you might think, sir, SI and International System of Units, there is no relation. If I want to write short form of International System of Units, I'll write IS units, International System Units. Sir, why is it SI? That's because this SI is an abbreviation, a short form of French word. What is that? Not required. Système International, something like that. Not required. Okay, all that you have to understand is, what is SI? Just a minute. What is SI unit? SI unit will refer to International System of Units. That's what you have to understand. Okay, good. So they have given some examples here. The SI unit of length is meter. And using this standard unit. So they defined what meter is. After they have defined what meter is, okay, using that standard unit, using 1 meter, then from there, every other device has been made. Now, the scale that you look at, the scale that we use, ultimately, where does that length come from? From the International System of Units. So they defined it long back. They defined it in 1900s, not long back, 1900s, just a century ago. They defined it, and we have been using it from then on. Obviously, changes were made to that, but almost it is the same. Okay, good. So using this standard units, measuring tapes, scales, and other measurements or other instruments are made. Is that clear? You can clearly see scientists arguing. Yes? Good. So here I'll again give you a simple example for International System of Units. Right. So mainly, or the basic quantities that we need or that we will be focusing on is length, mass, and time. For length, what is the unit that they decided? They decided meter is the SI unit and the symbol is small letter m. You have to be very careful about the small letter or the capital letter, small case or lower case or uppercase. It is small letter m for meter. Then you have mass. For mass, what was the unit that they decided? Kilogram. kg. Yes or no? Do you know what kg is? Yes, all of you know. Right? Then for time, they decided that it would be second and the symbol is S. The symbol is S. This is something you have to remember, all of you. Length, mass and time, they are SI units. Now you might think, sir, then we use centimeter, we use kilometer, what about them? We call them as other units, not SI, they're just other units. But this is what these are, standard units or SI units. Good? Okay, that's good. So it's a simple question for us. Very simple question. Is the length of your hand a standard unit for measurement of length? Yes or no? Or in simple terms, is hand span a standard unit for measurement of length? Everyone, yes or no? Very quick. Is that a standard unit? The answer is no. It is not. My length, the length of my hand or length of hand span, my hand span will be different from your hand span. It is changing, and standard units do not change. Right? So that's why the answer is no. Is that clear? Okay. And I think we'll continue this in the next class, right? So we discussed about what length is, what is length, distance between 2 points. And we mostly discussed about what standard units and the international system of units. What is the short form? SI units. Okay, just go through the notes and please do remember the SI units. Units of length, we'll discuss them in the next class. Okay, thank you, thanks a lot.
Hello students, welcome back to chemistry class at Gravity Cloud. Let's start the new chapter of separation of substances. Now in this chapter we will try to understand that how we can separate the components of a mixture. Right? Mixture? What is it? So let's start by basic understanding of mixture first. Right? Now mixture is what? If you go by definition of mixture, mixture is a substance, or we can say mixture are those substances which are made up of more than one substance. Or in another terms, if we talk about the definition of mixture, mixture is what? When two or more substances, they mix with each other without participating in the chemical change. The resulting substance is called mixture. Now the definition might be seem consuming, right? But don't worry. I will take some examples. I will take a lot of examples so that you can easily understand what is a mixture. Now for example, what happens? You take some sugar and you take some water, right? You take some water, you add some amount of sugar in the water and mix it by the stirrer. What will happen? We will get the sugary water, sweet water. Now you add some amount of lemon into it. Add some amount of lemon juice into it. What will you get? When you add sugar, when you add salt, when you add lemon juice into the water and mix it, you will get the lemonade. Right? You will get the lemonade. The lemonade is actually a mixture of water, sugar, salt and lemon juice. Simple. Because here what is happening? More than one substance is mixed together. Right? Water is one substance, salt is one substance, sugar is one substance and lemon juice is one substance. All these four substances, they are mixed together, or we can say lemon juice, salt and sugar, these three substances are mixed in water. When they are mixed in water, we get the perfectly tasty lemonade. And this lemonade is what? It's a mixture. Right? Similarly, if you take this example, here you see I have the candies, the different color candies here. Right? If you look at here, there are green type of candies, yellow, orange as well as maroon colored candies. All these candies, they are mixed together. Right? But they are not chemically reacting with each other. They are not chemically reacting with each other. They are just mixed together in one box. Let's say this is one box. In this box, I have put all these different color candies. So this whole structure, right? This is all called mixture of candies. It is called mixture of candies. Right? Our chapter is what? Our chapter is about separation of substances. Right? So separation of components of mixture, that we need to understand. In this chapter we will try to understand that how the components of the mixture can be separated from each other. Similarly, if I get the lemonade, I get the lemonade from water, sugar, salt and lemon juice. Then how can I separate? How can I separate these components individually? Or I can say, how can I separate sugar from water? How can I separate salt from water? Right? This is what we need to understand in this chapter. Here you see, we have the mixture which contains different type of candies, right? Colorful candies. I will do one thing. I will pick up the yellow candies first. I will pick up the yellow candies first and I will place it here. Right? Then I will pick up the orange candies like this and this. I will place it here. Right? Then I will pick the green color candies and I will place it here. Finally, what is left? We have maroon colored candies and I will place the maroon candy here. Right? In this way, what I am doing, I am just picking out the candies, placing it here, right? One by one. So what I am doing is, I am separating the candies. This is the separation. I am separating the candies according to their colors, right? I am separating the yellow candies from the green and red and maroon, right? So this is the basic idea about the separation of components of a mixture. That how can we do it? And if this is the mixture, what do we get here? We are getting the components of the mixture like green color, orange color, maroon color and yellow color. These are the different color of candies which we have, right? And I have separated these candies from the common mixture. Simple. Similarly, if you take the example here, you see we have berries. These are the berries, right? These are my, we say, berries. Simple. So in this case, in this bowl, you will say there is only one type of berries, red berries only red berries. Whereas in this bowl, you will say we have red plus yellow berries, right? That means it is a mixture of two type of berries. This one contains blue plus black. That means this bowl also contains two type of berries, blackberries and blueberries. This bowl, it contains only blueberries, only one type of berries, right? That is blueberries. This bowl again contains only one kind of berries, which is red. When it comes to here, it contains only yellow, right? Only one type. Here again, maroon or red. Here you see, it contains only black. What is the reason of showing you this thing? The reason behind showing you this thing is that some of the bowls, they contain mixtures and some of the bowls, they contain only one kind of substance, right? Suppose in this case, this bowl contains blue, black and yellow berries, three type of berries, right? Blue, black and yellow. So it is a mixture. It is a mixture. When it comes to this bowl, it contains only one kind of berries, that is red berries, right? So that means it's a pure substance, or we can say only one kind of substance. I will write it here. It has only one kind of substance. Simple. Understood? Similarly here, only blackberries, that means only one kind of substance. So that is the point. Definition of mixture says when two or more than two type of substances are mixed together, but they should not chemically react, the resulting substance is called the mixture, right? So all these are the examples of mixture. This is mixture, this is mixture and this is mixture. Similarly, if I take other examples, for example, seawater. Now seawater contains what? Seawater has water as well as salts. So seawater is the mixture of water and salts. Sand. Sand is the mixture of different type of particles. Sand is the mixture of different type of particles. Right? Paint. Paint is the mixture of color and oil. Color plus oil. Simple. Right? If you take the example of steel. Steel is again a mixture of different metals. It's a mixture of different metals. Simple. Right? Yogurt. Yogurt is a mixture of what? It is a mixture of water, right, plus fat, plus protein. So many things are there in yogurt. When it comes to seashells, now seashells, you see, there are different color of seashells, right? It does not contain only one type of seashells. It contains multiple type of seashells. So those multiple type of seashells, when placed together, they form the mixture of seashells, right? Similarly, cake. If you look at cake, there are different layers, right? And we know cake is made up of more than one kind of substance. It will have the cream, it will have the bread, it will have the fruits, right? Sugar also. So it contains more than one kind of substance which are mixed. Hence, it is again a mixture. Similarly, if we talk about water and oil, right? Water is one type of substance, oil is another type of substance. When they are mixed together, they form the oil and water mixture.